below is the power connector, and in the middle you have the connectors to the RS-232, and there's also a switch to turn it on.
Yeah, sorry. That's
the important one.
The switch is here, yeah.
The switch is here. If you really think you are disturbing someone, turn it off.
Yeah.
This works all the time.
Yeah, yeah. It's an actual like primary line power switch. It's not one of these soft standby kind of things. So anyway, so how did the first steps happen? Well, basically I bought the first, well, literally this unit, which is here, in 2006, if not earlier. I started to read some specs, started to build the cables for E1 and power. The power cable was particularly tricky, I can tell you, because the power plug has 4 pins, and according to the documentation, 2 of them are connected to phase. One is ground, the other one is earth. It's like, okay, 2 times phase, ground, and earth. So you connect the phase, like the actual line, to the 2 phase. No, it doesn't work like that. Anyway, so all that has been resolved. I bought an HFC E1 card, which is a primary ISDN primary interface card that's frequently used with asterisk, bigger asterisk installations, for example. It's supported by MISDN, which I even then intended to use as a base for the software. I also managed to find an ABIS analyzer on eBay. It's a handheld device meant for service people of GSM networks, which you can tap onto the ABIS interface, and then you can see what's going on. I also managed to get in touch with some other people who also happened to end up with one of these devices or more, luckily found somebody who has not only BS11 but multiple base stations, even different ones, and a base station controller who could send me traces of the ABIS protocol from an actual live test network. So using those traces, it gets much easier to do anything, but then unfortunately around that time I got involved with OpenMoko, so all that was halted or stalled, and yeah, well, Dieter came around in this year.
Okay, I was reading in Harald's blogs that he has the base station controller and the base station, and I really thought, oh, this is great. I always wanted a base station too, and I thought how to get one. Taking one of those bigger base stations apart, which you find sometimes near the road, was not an option for me. So when I heard that Harald bought one, I was looking on eBay, and luckily, it's really at the same time when I was looking, there was one offered, and I bought it. I also bought the E1 PCI card, the same one which Harald uses from Cologne Chips, and I'm coming from the Windows side. I'm not coming from the Linux side, so I thought I want to try it out on Windows. I got a reference driver from Cologne Chips, but this reference driver is actually a really simple demonstration of how this chip can be used, and it was intended for MS-DOS only. It does not use interrupts, it's just polling. Okay, I thought maybe a good idea to find out how this chip works and to see what is really going on the lines. Yeah, and I started with a very simple program, and step for step found out how to communicate with this base station. Of course, very useful were those traces which we received from another person who already traced the base station with a simulator and with an analyzer. He does not wrote his own software, but he had a simulator which could implement a base station controller, and it is mainly intended for testing these base stations. And the traces from this device were very helpful to get it up and running. This is just a simple screenshot of this initial program. Also, it is really polling and not doing anything fancy. In the end, it was possible to set up the base station, to let the phone ring, even to save some of the voice channels, saving in this case not really hearing it real time, but saving the file and later on taking a few command line tools and finally get out what I've talked into the phone a few seconds before. So this was the start from my side.
Yeah, so that sort of triggered me to revitalize my interest, also given the fact that I meanwhile had departed OpenMoko and had a little bit more time at my hands again. So actually this month, well, I wanted to start in September when I heard about the first results that Dieter was making. And then it took me some more time until I finally could allocate a time slice. Started to work with MISDN on the Linux side, and MISDN has a kernel-side implementation for the NT mode of the Q921, which is the layer 2 management protocol, the TEI assignment. Had to patch it a little bit to support multiple SAPIs and fix TIE allocations, but that's like a 10-line kind of package patch, so a very, very easy thing. Then I had to figure out how the new sockets-based MISDN APIs work, and then I came up with some event-driven architecture for the actual program, single select loop, no threads, nothing fancy. So the stuff that we've been working on here at the 25C3 in the last 3 days, actually, we added a lot of stuff to that. A number of my friends from OpenMoko and OpenEasyX started to add stuff. So now we have a libdbi, an SQLite database backend for the, HLR in quotes. It's not really an HLR, but it's basically a table which contains all the information that we're interested in so far or right now, like the TMSI allocations, the IMEI, IMSI, and so on. We got the paging to work. We have support for a configurable network ID, so we can say we are some other network. We have tried to say we are Iridium, but unfortunately the names of Iridium are not in the standard GSM phones. It would have been so fun if people look at their regular phone like, oh, Iridium, where am I? But doesn't work that way. So lots of debugging and stabilization, and the interesting fact was we have more than 1,000 test users. There's lots of voluntary test users here, which is a big surprise to me, considering the fact that especially 963 of those 1,000 test users are German German subscribers, where their home networks are here. So why would your phone ever not register to your home network, but to some foreign network? That's really strange. But despite that fact, people kept trying, and actually was a stress test for the entire software architecture. Would never have been able to debug that kind of load while sitting at home. One of the first things One of the first things that I did was to implement the IMSI and IMEI skimming, which is obviously fun to do, and I'll get back to that right now, actually. So what this is actually very simple. So when your phone wants to register to a network, so first of all, your phone decides that it wants to register to this base station, which is completely weird considering that it's not using an operator ID that you have. Like you have your subscription with T-Mobile or whatever, and we use a network ID that's 0101. It's a testing ID. It's not your home network. So we're not claiming that we're T-Mobile. This is not a kind of impersonation attack of any sort. Your phone decides, oh, we should register to this network. And then we basically, it sends a location update request, and we tell it, well, we don't know you. Please tell us your IMCI and IMEI. And the phone happily responds because, as I said, the network has the intelligence. The phone is just, a stupid device, and it just responds to whatever the network asks it for. And since the network is not authenticated, you get that information. So that response gets back. We put that in the database, and then we tell it, well, go away. We don't want you. So they happily go off, log into their regular network, and we have their IMEI and IMSI. Last night, actually, I didn't sleep, and I wrote a Perl script. Well, the Perl script didn't take me all night, but the last thing I did before writing the presentation was to write a Perl script to do some statistical analysis on the data we gathered. And I can maybe we have a minute later on, but basically, I have statistics from which country people are coming, to what percentage, and these kind of things. Another thing that you could do, which isn't implemented yet, is like statistics of what kind of mobile phone is the most sort of well-known one. Interestingly, there was one IMEI which was clearly spoofed. So there's at least one person here who had... There's one person here who sent an IMEI of 000123445. Okay. Now, mobile-originated call is actually fairly simple because once you say location update accept and the phone is basically in your network, then the phone can just dial any number. You make your outgoing call, you send a channel request, the network responds, channel acknowledge, and you deal with the signaling layer and get the connect. Unfortunately, in this, what I call OpenBSC software, we do not have the voice data processing implemented yet. I was hoping to get it done before this talk, but unfortunately we didn't. It's probably 1 or 2 days away. The mobile originated SMS is also like from the lower level signaling fairly simple. The actual hard parts are probably when you get into the parsing of the PDU and so on. But luckily, the person who just did that for a free smartphone on the handset side, well, was now happy to do the network side as well. So we have that implementation there. So you can send SMSs and it will be displayed on the Linux console. And actually, interestingly, last night somebody sent an SMS over our network. Like not one of us testing that, but somebody like, oh, I found a nice spot next to OpenWRT in the Hack Center. It's like, okay, thanks for telling us. So we quickly switched off accepting other people into the network again because, yeah, it starts to get nasty. So then we had the Egypt simulation. Apparently, GPS is illegal in mobile phones in Egypt. I tried to Google and then found a number of pointers. Apparently, that's the case. And mobile phones that are at least officially sold by operators in Egypt have the Egypt detection feature. So once they see a base station that has a country code of Egypt, they switch off the GPS. You don't even have to register to that base station. Just only if they see it somewhere in the vicinity, they say, oh, you know, we're now in Egypt, we have to switch off GPS. Which is interesting. Not all phones do that, but we've had some Nokia phones, and I think with the iPhone it was not quite clear, but apparently it also seemed that way. And yeah, so now basically you have something like a GPS jammer, not even doing anything related to GPS. So there's some other GSM-related free and open source software that I want to talk about before we get into the demonstration, which is OpenBTS actually, which is almost, how can I say, almost a good combination because we are using an industry-manufactured base transceiver station, and OpenBTS is about writing that as software-defined radio based on GNU Radio and USRP. And they've just had their 1.0 release, I think 1 or 2 months back, and it's sort of, they implement, the BTS is sort of a misnomer. They implement the BTS, they implement everything, and then attach that to I think SIP, voice over IP calls. And obviously there is quite a bit of overlap, and we are, I think right now somebody should land in Berlin 2 days delayed because of weather implications, and we will talk about how we can align our work in order to benefit from each other. In any case, the base station controller part is more something that I feel familiar with because it's network protocols after all, and that's sort of my home. Yeah, there's some other links that you might want to check out. We will put the slides online, obviously, at the Congress website, so you can check out all these links. A couple of thanks in the end to various people, and we're going to switch to a demonstration now in, well, about a second, where hopefully I will see some cameras rotating away from us now.